Hello everybody and welcome to the third video from the course Go from 0 to 1. And this video I'm going to talk about variables. Let's start, okay? Uh, to define variables, we say var. This is a keyword that defines that the next thing will be variable. Var, let's say name string, okay? Now name is a string variable. Okay, this error because it's unused yet. Okay, so if I say if to be name, it will give me an empty string. Okay, there's nothing but it is there, but it's an empty string because the zero value, we know the zero value, the value is given to the variable when it's not initialized. Okay, the zero value for integers is zero. It is zero. The zero value for strings is empty string, like this. We can say this, but it doesn't. It's not needed. Okay, if we want to give another one, we can say this. Okay, this is a value, real value, and we'll print it. So this value is inside this variable name. Okay, so this line says that variable name is a string, and its value is go. So here we give a name, the type. This is the type. We know the type, what the type is, and the type is. This is the type is string here, and this is the value. Of course, the value should be able to given to this type. So for it's not a string. So it says that cannot use for type and type integer. Okay, and type it integer as a type string, and type it because we did okay, it's just a literal. Okay, so in Go literals are untyped. Okay, so it is not like integer 8 or integer 32, 64. No, it's untyped integer. Okay, but can be given to any integer variable, of course. So now our number string. Okay. Okay, but Go is smart, so we don't need the type here because we give the variable a value. So this tells the compiler what's the type. Okay, this is a string. It's a clear string, so compiler knows that this is a string. So the type of this variable is a string. This called type infer. It infers the type from the value. Okay, this is very useful and beautiful attribute from Go. Okay, this is a way to define type. Okay, we can say another thing, number equal 45. Okay, and we just need to print it, so there is no error. Okay, we can say integer here or whatever we want, integer 8. Okay, now the variable is integer 8. Okay, but if we didn't mention it, it will be type of integer. Okay, let's say if empty dot printf t number. Okay, it will be integer here. If I say integer 8, it will be integer 8. Okay, so we need to focus on this thing. Do we need it integer or we need integer 8 or unsigned integer or what do we need? Okay. Okay, this is variables inside the function. Here the main function. These variables will not be existed outside this function. Okay. So at the end of this function, these variables will be removed from memory. Okay. We mentioned memory, so let's give it more look. Okay, let's look a little more about memory. I have This one, okay. Okay, what is this? This is it's like memory, real memory, like hardware. Okay, this is the RAM. Okay, random access memory. This is a 60-bit, 16-bit here. It's old, but no difference in idea. It's the same, just the size. Okay, and because it's 16-bit, so this is the addresses. Okay, well, let's explain more. Memory or RAM memory is we can say an array of cells. Okay, each cells has a size, but all cells has the same size, of course. Okay, so this how can we, in fact, not directly we, how the computer can access this cell? Okay, it doesn't need to go from the first cell. Let's say we need 15th cell. Okay, so we don't. The computer doesn't need to go from the first one and count to reach to the 15. Okay, this is will be very slow. Okay, and from the name random access memory, it's random access. It goes and to any cell anytime independently. It doesn't need another cell to go from. Okay, this can be done by addresses. Okay, so each cell has an address. Okay, each memory cell or memory I don't know what also called. I think there is another name, but okay, let's say memory cell has an address. So by this address, the computer can access the cell immediately and directly. Okay, so let's split this. Okay, now let's remove that. Okay, so let's say we like the picture. We have var x integer equals 1 to 3. We need to use it, so let's print it. Okay, now what this says, variable number is x. Okay, so when we define this is just the variable number. We say it's variable. It's not variable number, it's variable name. We say it's variable because we can use it interchangeably. Okay, no problem. Okay, it's variable name. It's the same variable. Okay, here and from its name variable, its value varies from one statement to another statement. Okay, now I said 123, then I say x equals to 1000 or whatever. Okay, so the variable name or variable is x here. Okay, the value is 132. This is value is which is stored in the memory cell. Okay, fine. This is the value of variable x. Okay, and each cell has an address. Okay, here it's 0802 in hexadecimal. This is a small address, but for our lovely x will be larger. How to print the address by this? Okay, before x. Okay, println the amber sign. The amber sign will give us the address in hexadecimal also always. Okay, so this is okay. It is large hexadecimal, but okay, we'll see, of course, until here. Okay, by hexadecimal. So this is the address for this variable, our variable. Okay, let's say the same for another one. Okay, let's say y, and here y. See y's address. Okay. Okay. Same. It's like there is 10 bytes between both of them. Okay. I know this is 8 bytes, and this is 8 bytes. The 2 bytes are gone somewhere, maybe for separation or something. Okay. So now we know that what we call the variable name, it's name for a cell. Computer in the level of machine language doesn't know anything about this X. Okay, it deals with addresses, but for Go compiler knows and deals with this number, this name. Okay, and when we say this statement, when we will be compiled, it will define, define variable number, store it, of course, and give him this value. At runtime, okay, this value will be loaded to the memory, and of course, this variable will have an address. Okay, now how if we said this? Okay, let's remove y. If we said not this but this, okay, it can be done directly. Okay, no, no, not this. It can be this one or this for make it complicated. This will print 123 also. Okay, so this is gives the address and the sign dereference. Okay, gives the value in the address. Okay, where we go, this is the address of X. Okay, and this is gives the value inside the address of X. Okay, I hope this is clear. So, the ampersand gives us the address, so now we have the address, and when we say or we receive the address by this multiplication, it has another name, I forget it now, it will give us the value. Okay, so we'll talk about this more in pointers lesson. Okay, so this is about each string takes this one, each variable, string, float, whatever, the same. They store in cell. Okay, sometimes it is not one cell. Okay, okay, I mean the variable can spread on more than one cell. It can start from here, for example, take 4 or 8 cells. Okay, as we said, this and okay, var y integer equals whatever fmt dot print y, not a printf. Okay, we saw this from 84 here to 50, from 48 to 58 here. Okay, so this one, okay, it takes 8 bytes. Of course, you know integer takes bytes on this 64-bit machine. So I think maybe the memory is 1 byte and it takes 8 cells, or could be 2 bytes and take 4 cells, or could be 4 bytes, for example, and take 2 cells. Okay, which it called word, machine word. Now I will not talk about this. It's not needed, no need for this. Okay, what I want to say this. Okay, fine, it's the same, but if I define another one, what I want to show you that from address X to address 1, it takes 10, okay, it's 10 bytes. Okay, but from address this Y, which is integer 8, to address Z, it shouldn't take 10 bytes. I suppose not. Okay, it's 1 byte, yeah, that's true, because at 58, it saves this Y. It's integer 8, it's 1 byte, and this is another 1 byte. Okay, fine, that's clear, right? Okay, I hope this. If you have any questions, any something not clear, just comment in the comments. Write your comment, and I will explain in the comments, or I will make another video and explain. I will try to do better. Okay, so this is about variables and memory. Okay, thanks for watching.